Welcome to Engineering Materials and Metallurgy. Today's lecture will be on phase diagram. A phase is a homogeneous portion of a system that has uniform physical and chemical characteristics. A single phase system is called homogeneous. Systems with two or more phases are called or mixers or heterogeneous system. Phase diagram represents phases present in metal at different conditions, that is at a different temperature, pressure and composition. It indicates equilibrium solid solubility of one element in another. Indicates temperature range under which solidification occurs. It indicates temperature at which different phases start to melt. It depends on temperature. Here you can see that. So here we have one material that is pure metal 100%. Here another metal 100%. When you mix both metals, so what is the thing you get? At what temperature it is melting point here, melting point of a metal here. Here another melting point of another metal here. So when you melt and mix, then this line, this what is known as liquidus line, this line what is known as solidus line, in between two phase region, that is liquid plus solid. Then above this entire 100% liquid, below this line 100% solid. Phase diagram represents the relationship between temperature and composition and the quantities of phases at equilibrium. Phase diagrams for binary alloy is the simplest. Cooling curves are used to determine the phase transition temperature. Temperature and the time data of cooling molten metal is recorded and plotted. One type of phase diagram plots temperature against relative concentration of two substances in a binary mixture called a binary phase diagram. So binary phase diagram is temperature composition map, which indicates the equilibrium phases present at given temperature and composition. So this is governed by what is a rule, what is known as Gibbs phase rule, that is F equal to C minus P plus 2. So where P is number of phases present in thermodynamic equilibrium, C is number of components, then yeah, system involving one pure chemical is an example of one component system. Two elements are two component system. Then F is the number of degrees of freedom, which means number of intensive properties such as temperature or pressure, so which are independent of other intensive variables. So in the P is equal to number of phases that coexist in the system. C is degree of freedom. C is number of components. F is degree of freedom. So degrees of freedom refers to number of independent variables, pressure and temperature. In practical condition, for metallurgical and material system, pressure is taken as constant. That is 1 atmospheric pressure. Then when you take a pressure constant, then it may be rewritten as P plus F equal to C plus 2 may be rewritten as P plus F is equal to C plus 1. Phase diagram represents the relationship between the temperature and composition of phases present at equilibrium. An isomorphous system is one which the solid has same structure of all composition. Phase diagram known as diagram of copper nickel, which is isomorphous alloy system. You can see that. So here you can see that 100% copper, 100% nickel. So the melting point of copper and melting point of nickel is there. Then the temperature is raised. So this is the melting point. Then after that it becomes liquid. So melting point of nickel is this one. After that it becomes liquid. So what will be the temperature, that is melting point of copper nickel alloy? So that will you can easily find out by using this diagram. So this what is known as a copper nickel phase diagram. So lever rule which is used to find out amount of phases present in the system. So here this is the, so here you can see that in this region what is the, suppose if I take WO at temperature T and this weight fraction of WO. So what is the quantity of how much amount of liquid phase and how much amount of solid present, that can be calculated by this formula. That is weight fraction of solid phase is equal to WO minus W1. So this is W1 then divided by Ws minus W1. Okay, this can be, so find out, you can easily find out the weight percentage of a particular, that is amount of phases present in particular weight percentage at particular temperature. So here also you can see that what is the amount of phase at B, that you can easily find out. Suppose when it, at this point it is completely solid, this point it's completely liquid. In between this both solid and liquid, that is a two-phase region. So that's why we want to find out the amount of phase present in two-phase region. So there are different invariant reaction, that is eutectic, liquid transforms into two solid, solid 1 and solid 2. Eutectoid reaction, that is solid 1 transforms into solid 2 and solid 3. Peritectic reaction, liquid transforms into alpha transforms into beta. Then peritectoid reaction, alpha plus beta, that is solid 1 plus solid 2 transforms into solid 3. So these are the different type of invariant reaction, so which is usually studied. So thank you very much for patient listening. Have a nice day.